Hey, how's it going, everybody? Welcome back. My name is Dustin. In our last episode, we quickly went over how to load textures to our square or our quad, and then also we went over UV values as well. I had a little bit of a homework assignment. It wasn't really a homework assignment, but you get the idea. If you wanted to try to create a function that generated the UVs for you, and you could pick a little piece of the tile map or a tile sheet that you had and see if you could generate the UVs for those. Those values were between 0 and 1, and that was a little task for you. We're going to go over how to do that today. We're also going to go over quickly how to create a 2D camera. So we're going to be going over orthographic projections and what we're going to need to make our 2D camera for our little game here. Alright, so let's get into it. Alright guys, let's quickly go over orthographic projections and how we're going to do the camera in our game. Orthographic projections are a form of parallel projections. What this means is there is no perspective correction and the parallel lines remain the same. Take for example a tall building. If you're at the bottom and you're looking up, it looks as if the lines are becoming more narrow the higher the building goes. This does not happen with orthographic projection. In orthographic projection, the projection lines are orthogonal or perpendicular to the projection plane. So let's take a look at this diagram here. The frustum created by the lines basically create a box for the viewing volume. So that means anything outside of the box will not be seen or appear on the screen. You can define the orthographic projection by 6 values: the left, the right, the bottom, the top, the near, and the far. These are the clipping planes. All the vertices that are outside of these planes end up being clipped and do not appear on the screen. So the viewing volume or frustum is basically a box. So if you see this orange arrow here, everything inside of that, inside of your left, right, bottom, top, near and far plane, that will be seen. Anything outside will not see. But since we're doing 2D, it doesn't really matter for us for the near and far values. They can be almost anything. But if you're doing 3D, it does matter. So let's quickly take a look at this camera class here. As you can see, the camera has a width, a height, scale, position. It also has 2 matrices, the camera matrix and the orthographic projection, that will be used to do the scaling and translating of our matrix. We will also have some getters and setters, and then an update function that we will use whenever there are changes to the camera's values. Alright, that should be enough for us to get started. So let's go to the code and get started. Alright guys, so the first thing we're going to be doing is downloading GLM. You can either go to SourceForge here, or you can go to GLM here, and then we just want to go to releases, get the latest release, and we'll just get the zip file. And once that's done downloading, you just go to your downloads, and we'll just extract it. So what I like to do is right here, just create a new folder. Let's call this GLM. Go into here, and all we need is this here. So you can cut this or copy this and just paste that in there. Once we have that, we can cut this, go to your dependencies, and just paste in your dependencies there. So now we have GLM, and now we want to associate it with our project. Okay, so where we left off last time, we could render this to the screen, and there was a task for you to try your best to see if you can use the UVs and just get a small piece of this, a 16 by 16 tile, if you could, and we'll go over that right now. But first thing we want is GLM, so let's go to our project, and we want it in our editor, properties, and VCC directories. Go to our dependencies, GLM, good. Solution dir. Alright. That should work for us. So back in here, we should be able to include GLM, and we got it. We don't need GLM yet because first thing we're going to do before working on our little camera that we're going to make that struct UVs. We'll just call it struct UVs and float U, V, width, and height. And we'll just there's our UVs, and then we're going to want to create a little lambda function, but we can do that right inside of main here. And because we're going to want to be able to access the width and the height of the texture, so we can just go auto generate UVs. And that'll be float, start X, float, start Y, float, sprite width, float, sprite height. Okay. So the first thing we want to get is the width of our tile. That will allow us to determine where our U and our V start in the texture. So if we get the width, we want to go U. So let's create a UVs first. This is just temporary stuff, guys. So let's make some temporary UVs. Now you wouldn't want to do it this way. This is just for testing is all. So we have our UVs, and then we go UVS.width is equal to sprite width divided by the width of the texture, and that's right here. So this is, we get the width from the load texture function that we did before, and then we can do the height, sprite height. Because the width is most likely going to be smaller than the actual width and height, we could put asserts in here to ensure that, but it will give us a value between 0 and 1. And then we can go UVS dot U is equal to start X times UVS dot width. And we can do the same for V. So if you look at this picture here, this is the one that we're working with right now, or the one I'm working with right now. This is 512 by 512, and each tile is 16 by 16. So say we want this tile right here, it'll be 1 over, 1 down. So it'll be 1, 1. So start would be 1, 1, right? And then our tile width would be 16 by 16. So sprite width, sprite height would be 16 by 16. And then we just say generate UVs, and we could just go 1, 1, 16, 16. All right. Now we're gonna have to change this here. So we have different values now. So we want our top left to be, if you remember from the slides, top left is your 0x and your 1, or 0U and 1 for V. So we can go UVS dot U, and then UVS dot V plus UVS dot height. And then this one's going to be our bottom left. And that's just going to be UVS.U and UVS.V. and bottom right will be 1, and this would be 0 because it's bottom. So uvs dot u plus uvs dot width, and then this is 0, so it's just uvs dot v. That's our bottom right. And top right, so that's what this is going to be. Top right is going to be both. Now uvs.u plus uvs.width and uvs.height uvs.v plus uvs.height. Now if we run this, it should work. Okay, so it's not showing anything. And that's the reason there, because we didn't change this to height. Well, that might not be the reason, but it's one problem. Oh, and this should be start Y. The problem with copy and paste, guys, is you'll make mistakes, or you can make mistakes. Let's run it again. Awesome. So if you see that it's the opposite way now, because we changed everything back, but we're going to handle that when we use our camera. We're going to flip our projection with the camera. So if we come back here, so where was that? Let's look at the picture again. Here. So that is this one, but it's opposite. So it's upside down. So it's probably switched to this side now because we switched everything back to be normal. But we need to invert the Y of our texture in order to get it to go from the top left down. Let's try to get this one here, or something down on the bottom here. So we know this is 512. So if we take out our fancy calculator and we go to decimal, 512 divided by 16 gives us 32 minus 1, so 31. So 31, 30, 28, or 29, 28. So that I will be 28. And we won't be able to see it because it's black. So let's change, well, let's put that in here first. So 0 and 28. And let's change our clear color, wherever that is. Clear color. And we'll just change it here to white. Run it. Cool, we got our eye, and it's off a lot. It's not the direction that we want it to be. But it's still our eye, and it looks like our UVs are working correctly. Now, I recommend you play around with these values and make sure that they're correct. What's the worst that could happen? That's how I always say. Okay, so now let's quickly make our little camera class. So up here, we'll put it right above the UVs. We'll just say class camera 2D, and we'll have some private, and we'll have some public. In order to get the ortho from GLM, we need to include it. So we need GLM, GLM, GTC, matrix transform, .hpp. That'll allow us to use the GLM ortho, which will get that, so we can create our orthographic camera. So what do we need here? So we're going to need a width, a height, and we're going to have a float for scale. And we're going to have GLM vec2 for the position. And we're going to have GLM mat4 for the camera matrix. And we're also going to have on ortho projection. We're going to need the ortho projection to do our scaling, translating of the camera matrix. And then we're also going to have a bool mb needs update. Now, we only want to update the camera if something changes. That would be the scale, position, or the matrix values. Then we want to update it. Other than that, we don't need to update the camera. And in public, camera 2D. And we'll just take a width and height. Set the scale to 1. You want to set the scale to 1 because 0 will be nothing, and then anything in the negatives will invert everything to the other way. It would be upside down if it goes into the negatives. And then we're going to have our position, and that'll just be GLM vec2 at 0. And then our camera matrix, and that'll just be and then the ortho projection, and then MB needs update. We want that to be true, so when it first updates, when it first goes through the update, it actually updates the camera. All right, and you know what? We can just create a default that calls, and that'll just be 640, 480. So that would automatically call this constructor here for us. So inside of our constructor, we're going to want to actually now set up our ortho camera, or ortho projection. So we go M, so we can just say this, init ortho projection, and then we just say M ortho projection is equal to GLM ortho, and that'll be so we have our first thing is the left, so 0.f will be our left, and we'll just say, put a comma, and we'll say left, and then we'll have the right, and the right will be the width, static, cast, float, and width. And then we'll have our bottom. And then we'll have our top, and that'll just be static, cast, float, and height. Now, if we swap the bottom and the top, it will automatically flip our textures for us. That's what we're going to do later, but right now we're just going to do this for now. And the near and far can really be anything when it comes to, because we're doing 2D, so we don't care too much about depth. The near and far doesn't really matter to us, but we'll put it in anyway, and we'll just put it -1.f. That's our near. and 1.f. Var. Okay. And right off the bat, we can have there's some other functions that we could put in there as well, like set position, set scale, all of that. We don't really need those right now, so we'll skip that for now, but there are two functions that we are gonna need. We're gonna need to get the matrix, the camera matrix, and we're also gonna need to do the update. So let's do the get matrix first. So we just do inline glm mat4 get camera matrix. And we're just going to return the camera matrix. And then now the update function. And that's just update. First thing we're going to do is if not MB needs update, just return. So if we don't need an update right now, just leave the function. And if we do, glm, first thing we're going to do is translate. So let's make a vec3, and we'll just call that translate. And that will be minus m position dot x and minus m position dot y, and then 0 for the z. We don't want to change that at all. And then we'll just go m camera matrix is equal to glm translate, and glm translate needs a mat4, and our mat4 is going to be our projection matrix, and we're going to send in our ortho projection and the translate. And now we're going to do our scale, so we can just go translate and scale. And that's just going to be glm vec3 scale. And that's just m scale, and 0. And then same idea, we want to do the scale, glm scale with our camera matrix. Camera matrix is equal to glm scale, and then if we just want to send in an identity, so identity matrix, and the scale. And then we want to reset our update. Since we've updated, we don't need the update. So MB needs update is equal to false. Cool. All right, so we got our little camera class started, and now we can come down here to our shader because we have to add in our projection. So let's go down to our shader, where that is. So our vertex shader here, and let's just create our camera. So create a temp camera, and that's just camera 2D, and we can just call it camera. We don't have to put anything in because we have our default, and the default is the size of our window. Well, let's just verify that. What's our size? What's the size of our window? So we made the size of our window 480, 480. Let's make it 640, 480. Okay. So now we need to multiply our position, or our vec4, a position, by the projection that we're sending in. So we need to actually create a uniform, mat4, and that'll be the U projection. And then once we have our uniform in there, or projection, we can just put it here, U projection times vec4. There we go. Oh, not project, shun. All right. So after we got our shader, we got our camera, we now have to try to use it when we draw. So after we do all of this, Now we're gonna have to grab our camera matrix. So the first thing we're gonna want to do is go auto projection is equal to camera.get camera matrix. And once we have our camera projection, we need to now get the uniform location for the shader. And the uniform location that we're looking for is for the projection. So we need to go GL uint location is equal to GL get uniform location, and that is the shader program that we created, and we want U projection. Now, once we create our own shader class and we abstract everything away, we won't want to keep going get uniform location. We'll want to create a cache where we're basically, or a vector or a map basically of where those locations are. So we'll get it the first time and then we'll have it in cache. And then we'll check to see if we have it already and then just use that location instead of constantly querying for the location. So then now that we have the location of the projection uniform, we can now set it to the camera's projection that we have just got. So let's go GL uniform matrix for FV, and that's the location that we're sending in, 1, GL false, because we don't want to transpose and the count is only 1. And then our float value is our projection. At 0, 0. All right. Is there anything that I have to do now? Texture, draw. And all right, so let's run this right now. I believe it'll just be an empty screen, or you'll have an empty texture. Then we won't see our texture now. Oh, we did see it. Interesting. And we did see it because we're not updating our camera. That's why. So in our while loop, the last thing, let's just update our camera. Now we wouldn't do this here. Eventually we'll have a nice application loop and it'll make more sense, but right now we're just going to update it there. As soon as we update it, we shouldn't see anything now. That's making no sense. All right, so one issue, I forgot that this is a multiply. You're multiplying by the scale. So when we run it now, we shouldn't see anything, and that was what I expected. So now, why are we not seeing anything? Well, our vertices are 0, -0, so that everything is out. That's outside of our frustum here, so we're not going to see that. So now we need to change our vertices to a location where we can actually see. So -5 here, we can't see these vertices. Any of them that are in the negative currently, we can't see those. So we need to change this to be within our new left, right, and bottom and top. So what we can do for that is just here. So let's say we're 10 pixels over and 26 because it's 16 pixels wide. 10, 10, this bottom left, and 26, 10, and 26.f, and 26.f. Let's see what that gets us. Yay, there it is, way down here. So you see our texture is right there, it's in the bottom, but I want it up here. So what we're gonna do is go back to our camera and switch our top and bottom. So our top will be our top here, our top left will be our 0, 0. That's where I'm setting our origin. You can set your origin anywhere you want, but right now the origin is down here in our bottom left, the 0, 0 point. I want our top left to be our origin. You can set it to the center. A lot of people like to set it to the center, but I'm going to set it to the top left. And all we have to do for that is go to our, when we're loading in our ortho camera, we just change our top with the bottom, and that should work. It should put it up to the top and also flip the texture. Now you can't really see that the texture is flipped properly because it's so small, because that's actually a 16 by 16 pixel. So let's go and just increase, let's actually add a way to increase our scale real fast. So we'll just go inline, GLM. Actually, sorry, we don't need GLM. So let's just go here, inline, void, set scale, float, and then just say scale is equal to scale. I didn't put a name in, I should put a name in. Scale. And then since we're changing the scale, we also need to update. Cool. And then go back to where we initiate our camera, or initialize or create one. And let's just set the scale here, camera dot set scale, and we'll just set it to 5 for now, 5.f. All right, so you see we got our eye there, but you see we have this black around it. That's because we're not dealing with the alpha channel right now. So what we can do to deal with this, we can add in our blending, and we can do that when we're initializing. All right, so after we've loaded everything right here, we can just enable alpha blending, and for what we want, we're gonna go GL enable, GL blend. And then we also want to go GL blend func, GL source alpha, GL1 minus source alpha. And then run it. Awesome. So we got our eye, we got our camera working, we're working in ortho. There we go. So we got our 2D camera going. All right, and that's enough for this episode. Hopefully it made sense. In the next episode, we're going to actually start to abstract a lot of this stuff away. So we're going to create a shader class and look into how we're going to do that. And we're also going to create a texture class. And then we're also going to need, it makes sense, instead of having these vertices here and having to declare them like this, we'll create a vertex class which will be able to separate these, and we'll have position, we'll have UVs, we'll have color, and then we also will have, for later on, we'll have to add the entity identity. But we'll talk about that in another episode. All right, if you have any questions, please let me know. If you have any comments on how I could make the videos better, please don't hesitate to leave a comment below. All right, I'll get back to you as soon as I can. Have a great time, and I'll see you next time.